Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, use Descartes' Rule of Signs to determine how many positive, negative, and imaginary zeros are possible in the function f of x equals 4x to the fourth minus x cubed minus 7x squared minus 6x minus 1. So what are the steps for finding the possible positive, negative, and imaginary zeros for a function? Here they are. So this is Descartes' Rule of Signs. Step number 1 is find the number of positive zeros. So to do so, you count the number of sign changes in f of x. So the number of possible positive zeros is that number or 2 less repeatedly, but it can't be negative. And it can't be negative because you can't have a negative number of zeros. All right, so let's go ahead and do step 1 on the side. We're going to bring down our function here. So are there any sign changes here? So this goes from positive to negative. Oh, so there's 1 already. And then it goes from negative to negative. And then that's not a sign change. And then a negative to a negative. Again, not a sign change. Negative to a negative. So there's only one sign change here for step 1. So that means if we bring up our chart here, so we have one possible positive zero. So then we know here is going to be 1. All right, let's move on to step 2. We're going to find the number of negative zeros. So to do so, you find f of negative x. Then you count the number of sign changes. And again, the number of possible negative zeros is that number or 2 less repeatedly, but can't be negative. All right, so let's go ahead and do step 2 on the side here. So I'm going to bring down our function. And we're going to plug in negative x wherever we see x. And I'll write it in red there so it's just easier to spot. So negative x to the fourth minus, and we'll plug in negative x here. Cubed minus 7, plug in another negative x. Squared minus 6. And then we have negative x again. And then minus 1, we're running into our chart here. Let's move our chart over. There we go. Okay, so now we just need to simplify this here. So this is going to equal negative x to the fourth is positive x to the fourth times 4. So you get 4x to the fourth. And then here you get negative x to the third, which is negative still, times a negative, so it's positive. And then here you get negative x squared, which is positive x squared times negative 7, gives you negative 7x squared. And then you have negative 6 times negative x, which gives you positive 6x. And then we just bring down the 1. All right, let's count the number of sign changes. And this will give us the number of negative zeros. So looks like positive, positive, so no sign change, positive to negative, so that works. Then we have a negative to a positive, and then a positive to a negative. So there's 1, 2, 3 sign changes here. So there can be 3 or an even number less than 3, which in this case works because that would be 1. All right, and then we know there's for sure one positive 0 here, so we can bring that down to the second scenario as well. All right, so now we have to figure out the imaginary roots. So to find, that's step 3. To find the number of imaginary zeros is basically the leftover zeros. So you subtract the degree of the polynomial by these guys, the pluses and minuses, and whatever is left over, that's how many imaginary zeros there should be. And really important, imaginary zeros are always an even number. So if you ever get a 1 or a 3 in this column, we did something wrong. All right, so what's the degree of our polynomial? Well, it's the highest exponent of x. So in this case, it's 4. So let's go ahead and label that. So that 4 there is our degree. So that means in any scenario here for our zeros, these need to add up to 4. So we have 1 and 3, so that's already 4. So that means we're going to have 0 imaginary zeros in that case. In the second case, we'll have 1 plus 1 is 2. And remember, we want a total of 4, so we need how many more here? We need 2, which is a good sign, because remember, imaginary zeros must always be even, because they always come in conjugate pairs. All right, so therefore this is our possible combinations of zeros that could happen. There's two scenarios. This one here, the 1, 3, 0, and then the second one is 1, 1, 2 for the zeros. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.